Okay. It's an array and a collection of a variable of a certain type.
¿Mande?
What did you say? Ahorita que me-
Yeah. Are you guys here today? Good, good.
Please mute the mic.
You went.
Thank you.
You are welcome. Okay. And an array, a collection of variables of a certain type that are contiguously in a memory. A one-dimensional array, a list of related variables in the general form of one dimension, a type variable name and the size. Okay. That means if you want to make an array, then you can see the example here. Okay, integer sample. Okay, just wait for me. I want to open the PowerPoint. Just 1 minute. Okay, so the general form, that means you get a type and a variable name and what size. Okay, in here, you can say integer. That means the type. They can be any type. Integer, double, float, whatever. Name will be sample. And they will be, the size will be 10. Okay. Now, I will be asking you this thing. If you get integer I, okay, equal 5, or you can get double y equal 12.5. Okay, now what is the ith? Tell me what is ith?
The array is the name of the array.
No, not array here. What is ith?
Oh, sorry, it's a variable.
If you're talking about the software and you say that's a variable, okay. However,
It's a space in memory.
It's a location?
yeah,
In memory.
that basically, I basically just address, okay, or location. in memory. Is that right?
Yeah.
Yes, sir.
And they will be stored for the integer. That means x equals 5. Later on, you can say c equal to x squared. Then you can get 5 times 5, they will be 25. They just store the value into the location I. And that will,
Mr. Pham,
yeah, go ahead.
what is the size of bits for this integer?
Now, you understand that you open the first handout, you're looking into that, depending on your computer. They get 16-bit. That means I will be can store any value from minus
Okay, 16 bits.
from
Okay,
minus 32
thank you.
to 32,000. If you're looking in the first handout, and if your computer is 32-bit, then that will be make a bigger number. Okay, so if we're talking about software, that's just a variable. If you're talking about a hardware, that will be an address or the location in the memory. And the second double Y, exactly the same thing. However, Y will be a content with the decimal number, like 12.5 or whatever. Same thing, just a location in the memory. So you understand it. In the computer, only thing they know that will be binary. 1, 0, 1, 0, 0, 1, whatever. Just the binary. Okay? So if I want to know, okay, the location in binary, how do I know? Who knows? Tell me. If I say, I want to know what exactly the location in the memory of the computer, how do I know? Who know how?
Call a function for it?
No, what I'm saying is, integer x equals 5, and I already telling you, I just address a location in the memory. You're using I, the thing is human, using alpha beta. However, the computer only using the binary.
So 0101 or 0.
Yeah, whatever. However, my question is, if I really want to know what exactly the real memory in a computer, how do I do to get that location? Okay, look like the guy don't know. So
You can use a pointer.
no. You know that? Yeah. Right? That bring out. That's the instruction operator. Okay? So when you say CL, instruction operator. Now, if you want to bring it out the value, okay? I can put it here, value. Okay? And now I put I. So that they will be display value of I, and they bring out will be number 5. Okay, and you if you still memorize, okay, then you can say a value I, that means a string, right? When you run it, they display exactly value I. You cannot change anything. And now you get another instruction operator, and you want bring I. That means bring the content of the I. So the answer will be bring it out number 5. Okay, and now you want to print. Okay, and you say I want real address. Okay, instruction. Now you have to use an ampersand. I. Okay, ampersand I. If you're looking on the first hand out, then you can say they will be displayed exactly binary number like 1, 1, 1, 1, okay, to whatever, okay. So they will be given to you exactly the binary number inside the computer. If you really want,
Mr. Pham, can you do that as a comment next to the N% up top? Can you put that number so we'll know in the future where it came from?
ampersand I, right?
Yeah, after the semicolon, can you put that binary information after that? Put a //
Okay. Now I can say computer, okay, will display okay, binary location. If you want to see the binary location, that means you're using ampersand I or ampersand Y, okay? So they will be given to you. This is really exactly binary location in the memory. I said, you want to learn, then the introduction, the chapter will be given to you. Read it 100 times, not only 1 or 2 times. You're able to
200 times.
Yeah.
A million times.
I did the same way. When I start, I cannot understand, but reading over and over. So that's why up to the certain point, then you can know everything. Okay? So basically, that will be telling you what? When you get into the act, so basically you only store only one data. Okay? However, normally they have to want to store more data, okay, at a time. So that's why they come up with, they call array, okay? And that's what they're telling you here. Okay? You want to get the array. Then you have to get the type. They will be what type? Character, integer, double, float, or whatever. Then you get the name. Then you get the size. Okay? I can give it to you here. They say integer. Okay, sample. And you open. You say 10. So that will be a declaration telling the computer you get the array will be contain integer and they get 10 elements. Okay, so you can see how many locations in here in this sample.
10.
Or is it 11 because it starts at 0?
There will be a 10 location,
Okay.
right? You want 10 location. And the location will be start from 0, right?
0 to 9.
Exactly. 1, 2, 3, 4, 5, 6. Okay. 7, 8, 9. So basically 6, 7. Okay, so basically in this array, you get a 10 element. Then you can store the data into location 0. 1, 2, 3, 4, 5, 6. Okay, 7, 8, and 9. So you can see the difference between integer sample. Okay, now if I say integer sample, so that sample only store one data, right? But if you make an array, they can store 10 data. Normally, they have to using an array. You can see in the company for employees, they not get only one. They get 1,000 or 2,000, 5,000. So they want to store the data, then they must be using an array. Okay? Depending on how many address you want. That is talking about array. And the array, when you say integer, they only store integer value. If you put a 12.5, they ignore 0.5. Okay? They only integer, no decimal. If you want decimal, and they store only decimal. Okay? And now, an individual element within, okay, an array is accessed by you of an index. An index describes the position of an element within an array. In C++, all arrays have 0 at the index of their first element. No matter what, the first element will be 0. The thing is, we start from 0. Okay? Since the sample had 10 elements, it had index value of 0 to 9. The first element in the sample 0, and the last element is sample number 9. Okay? The bracket tell the compiler that we are dealing with an array. So you get any question by the definition for an array. You can make an array you want it. How many elements you want it. Okay?
So Mr. Pham,
Yeah.
in the example, it say in sample 10, so that store integer only. But if we do a float sample 10, then that would able to do decimal then. Is that correct?
Like if you're using a double or float,
Okay.
then
All right.
it store 10 point whatever.
Okay. All right. Thank you.
Yeah, I said this is a very, very beneficial and for anyone. Keep want to moving up. Now software will be a very, very important. They try to give you the basic. I like to take the software. Okay. Now, basic property of an array. Okay, the individual data item in the array called elements. All elements must be the same data type. You see that? If you want integer, they will be integer. If you want double, they get a decimal. Or character, they will be just character. All elements are stored continuously in the computer memories. The subscript of the index of the first element is 0. The name of the array is constant value that represent address of the first element in an array. Okay, let's see what they try to do here. Okay, I try to make it bigger so you guys can see. Okay, this is a sample. Integer sample 10. Integer t. Now, you understand you get a 10 address. So if you want to store data into that own location, then you must be using the for loop. Same thing. If you want to take the data out from an array, you better using the for loop. Okay? For this example here, first thing they say for t equals 0. T less than 0, then you increment t. That means they try to make 10 locations. Okay? Then they say cout sample per t. That means sample is the name of the array. T will be varied. And that will be inline. Okay? So basically, if t0 and they store equal a sample first one 0 and the next one will be 1. They will be varied. Okay, that is how you can store in data into an array. So you want to store data into the array, then you better using the for loop. Okay, let's see. Define an array. Write array type followed by valid array name and pair of the pair of the square bracket enclosed by a constant expression. Constant expression define the size of the array. Cannot use variable name inside the square bracket. That means inside the bracket here, you cannot using variable name. For example, you say integer x and you put x inside bracket. They're not working. String. Common use one-dimensional array is to create a string. In C++, a string is defined as a character and array that terminates by the norm. A norm specified using /0 and is 0 because the norm terminator is declare a character array to be 1 character longer than the largest string that it will hold. Okay, and also here they given you some, okay, some string library function that we already have. You want to copy string copy, okay, and the string cat string length. That means you want to know the length of the string or string compare. Okay, let's see. To upper or to lower, okay, this is a more go into the software. We don't need that. Now, you get the 2-dimensional array. I just let you know we're not using it. They say they get an integer num. So integer num means the num will be the name of an array. And they will be contain integer. And one will be 3, another will be 4. Okay, declare 2-dimensional array. Row will be 0, 1, 2, 3, 4. And the column will be 0, 1, 2, 3. Okay, so basically they will be stored, okay, inside that array. In order to do it, then you have to using 2 for loop, not only 1. The first they say 4 column, and the next will be for the row. Okay, I can tell you they will be look like.
Hey, Mr. Pham,
Okay,
I have a question.
Yeah.
In your declaration, when you have a integer number, parentheses 3, and then parentheses 4, always the first parenthesis is to define the number of rows and then the number of columns?
yeah, that is a basic. That means you get a 2 dimension, not the one I just talked to you.
So basically you're going to get a matrix
Exactly.
of 3 columns, of 3 rows, 4 column.
Okay, so you get a 0, then you get a 1, right? Then you get a 2, then you get a 3. How many rows? 4, right?
No, in that case,
You see it right here. Row,
row, you have 4 row
4 rows,
and 3 columns.
every 3 columns. Okay, now let's see. Okay, 3 columns. That means you get 0. Okay, 3 columns. Okay, so basically 1 column, 0, 1. Okay,
Should it be 0, 1, 2 for 3 columns?
that's 3. Right?
Yeah, no, I'm asking for 3 columns.
That's
'cause
what 0, 1, 2.
Yeah, that's what I said. Yeah,
That is 3.
that is 3. Yeah.
And basically you can get that one will be 2, right?
But I'm a little bit confused because the term column is for vertically and row is horizontally, right?
Let's see.
In matrix, algebra of matrix,
In matrix here, you get
matrix, yeah,
column
column is vertically
0 to 3.
and row and horizontally.
Column will be 0 to 3.
Yeah, it looks like it's written backwards. I agree.
Yeah, looks backward your matrix, Mr. Pham.
Okay, that means you get 0, 1, 2, 3, 4, right?
Going up and down, yeah.
0, 1, 3, 4.
Mr. Pham, I don't think there should be a 4. If it's 4, then
Yeah,
it's
I agree with that too.
Now take the 4 off. Take the 4 off.
0, 1, 2, 3,
0, 1, 2, 3.
Yeah,
and then 0, 1, 2.
And 0, 1, 2.
right. Take the 3 off. There you go. You got it, Mr. Pham.
So now if you're looking into here, they say t equals 0 and t less than 3. Then you increment t. So the first one, what you get? T equals 0. Okay. Then you go into the second loop. Also t equals 0. We're looking for the okay, t equals 0. Okay.
Yeah, but looks like the loop is not going to work in the way you have it, Mr. Pham, because first is going to count from 0 to 3, and then you have a nested loop that is going to count from 0 to 4. The nested loop is bigger than the main loop.
Okay, now when they say 4 here, that means they get 4 location.
That 4 should be the first loop, the main loop.
Okay, the first one you get a 0, 0.
Mr. Pham, if you scroll down on the PowerPoint page you're on, there is a little grid.
The first location will be 0, 0. T equals 0. Then you go to the next. I equals 0. Okay. So if t equals 0, so if I put in here, okay, t equals 0. T equals 0. And at the same time, I equal 0. That's the first location. What the next?
1, 1.
Okay. Now, if you're looking into the loop, and you can see the first doing 1 time, the second loop doing 4 times. You see that?
Oh, okay. Okay, got it. Got it.
Okay. So the next will be t equal 0, right?
Yeah, and I should be 1, right?
Exactly. I should be 1. And the next will be t equal 0.
I equal 2.
Yeah. I equal 2. Okay. If t less than 4, okay, so the first t equal 0, then the increment, they will be equal 1, 0, 1, okay, then the next one, 3, then you get the next one.
T0, Y3.
Okay, t equal 0, and I equal 3.
3.
Okay, that's a 1 round.
Now, is that a
Oh.
row, a column, or what? I'm confused.
This is the row here, first one, right here. And you can go to the next row. So the first one in the for loop, they doing the row. Inside the row, they have to do 4 times for the column.
Yeah, but basically the question of Mr. Smith is T symbolize the row and Y symbolize the column.
Right.
Sorry, I, not Y, I.
Now, on the second row, second time, copy that one. Okay. And you can see they will be look like. Now, the row will be go to the next one.
1, T1.
1. And you can see that will be 1. That will be 1.
All the T's.
Yeah. And so on. So that means this is a 2 array dimension. Okay. And if you can see the next one, they will do the same thing.
So the next one will be T equals 0, and then the I's will be 0, 1, 2, 3.
They're all the time. 0, 1, 2, 3.
Maybe
Okay.
I'm
All right, so
misunderstanding.
let me jump in. I just want to make sure I get this right. The first one, all the T's were 0. The second one, all the T's are 1.
Right.
And then the third one, all the T's would be 2.
Exactly.
Yes.
Exactly. That
And how many would we have to do like that? How many would we have to do like that?
and you can see in here. T equal 0, T less than 3. That means 0, 1, 2. That's it. If they less than 2, they keep doing. Less than 3. Okay. You see the for loop for T0. T less than 3 and T will be blood T.
Now I see why you said read the book 1,000 times, Mr. Pham.
It's not simple.
No, it's not. It can be confusing.
See, that's what they given to example here.
Yeah, Mr. Fan, only one comment. In the previous page, there, your comment when you say declare two-dimensional array row, row should be 0, 1, 2, and a column should be 0, 1, 2, 3, 0, 1, 2, 3.
Or
Looks like there is backward.
Yeah, if you look at the diagram right here on this page at the bottom, he's right.
Yeah. Based on what you have in the matrix in green, the diagram looks like your comment is backward.
On your notepad versus the graphic on the PowerPoint.
you mean that for T0, T3 for the row.
The row, based on your diagram, the row should have only 3 rows, and the column should have 4 columns. But you have
You did it right.
backward.
We gave you the wrong advice. We told you to do it backwards.
So basically you want to say that will be row.
Just on your notepad, the way that you had it on your notepad, it should be the other way.
Okay.
And also I think in your comment that you have the second line on this slide.
Okay, so that will be 2 dimension in the array.
Hey, Mr. Pham, I'll get a baby question. It's not that big of a deal. For your four loops there, one is a capital for F and one is a small f. Is that correct or is that incorrect?
You mean for here?
Where you got FOR before the loop.
Before the loop.
Yeah, you got a capital F on the top one and a small f on the bottom one. And I'm asking you, is that right? Because I always saw the for loop done with a small f in C++.
And we know it's case sensitive.
Right, that's what I'm asking you.
Okay, that you correct.
So that for on that line where if you go up,
Yeah,
where
I
it
know.
says capital.
No, the thing is that that is, I copy it into this software, so automatically they make a capital on the PowerPoint.
But it's supposed to be a small f though.
Right. Exactly.
Okay, thank you. That's what I was, because as Adam said about the case sensitive, that's what I was worried
Yeah,
about.
we don't have a that for. If you're looking into the first handout, they must be lowercase
Right, exactly.
and not be uppercase. Like you see, when we say we print C out, see that in the PowerPoint. When you copy it into that PowerPoint, automatically they print it upper, but that is not right.
Right.
We're talking for the people understand the software and they know that just not a problem. When they coding, they have to be lowercase, not capital.
Right.
Okay, so you see nothing to do with an array. Okay, only thing is they using to store more data. So that's why in the lab we're using only 1 dimension. So we can testing for different data at a different location of the memory.
Hey, Mr. Pham, what they were trying to say before in your second line where it says declare 2-dimensional array row equals 0, 1, 2, 3, 4. Shouldn't that be changed to 0, 1, 2?
Which one? 40, 0.
On your second line.
This line or second?
Gotta go up to your second line. We're right under 2-dimensional arrays, the title of the PowerPoint.
You want talking about this one, right?
No, not at all. Second row. Or second row.
Second row.
Go up 4 lines. Go
I
up.
think he's talking about the line under where it says two-dimensional array, the big black thick letters. Now
Correct.
go down one, go down one. Yeah, right there. No, you went down too far.
You mean
Oh,
The second row, right under two-dimensional arrays. That line right there underneath.
Oh, Mr. Pham.
Second
then the-
line.
And then say declare two-dimensional array, the
Yeah.
Correct.
declare.
Row should equal 0, 1, 2, and column should equal 0, 1, 2, 3, no 4.
Correct.
okay, 0, 1, 2, 3. Yeah, I agree. That one, I already prepared fairly long time ago. Right?
No 3.
Get rid of the 3.
And then add it to the column.
No 3, right?
No
Right.
3.
And then, at
0, 1, and 2.
and then at the end of the line where it says column, that should be 0, 1, 2, 3.
Okay, 0, 1, 2, 3. Okay, thank you.
Comma
Wonderful.
3.
Thank you.
All right, Mr. Pham, you get your certificate.
Yeah, thank you.
Okay, now I want to talking about the lab 11. Okay. This is just a memory, almost the same what you did for the lab 9. Only this time I want to see how many students know what to do. Okay? If you're looking into the schematic, that will be memory here. 8-bit data. 8-bit data. Okay, 8-bit for address. So now data will be sending from port A.
So this time it's parallel data.
Okay, parallel data. So as you don't try to using the serial data like the other lab. Some people not quite understand. So that's why they still copy that and try to use it. That's wrong. This time we're not using 74, 164. That's
Right.
serial to parallel conversion. And this time they're using 8-bit port A. If you want to write in data AA, you can write to port A08 AA or 55, whatever.
That's just a buffer, Mr. Pham?
That's a buffer 541.
Right.
Right.
And they routed. That means everything coming in will be automatically coming out. Get that?
Right. And go into U2.
Okay, now go to U2, and U2 will be 373.
That's like a D flip, but it's a latch, right?
Right. Okay, just a minute. I have to give you guys a note here. Okay. Otherwise, you don't know what's going on. Okay, A1, just the buffer. Okay. And they will be enabled all the time. That means whatever coming in will be automatically coming out. Okay, and then basically I can put in here also L1, okay, 74, let's see, 541. Okay, and now L2, okay, the park will be 74, 3, 7, 3. Okay, what is it? D lab. Okay, they will be a D lab. You already learned on the D flip-flop. D flip-flop, they can be X trigger. That means they need a clock. Or they can be a latch. Okay, now to get the data from input into the L2. Okay, to get data from input. Okay, to L2. Now I say just to L2, that means they go inside of L2. Then what you need to do?
Hey, Mr. Pham, if I could just real quick, you're saying, okay, the data went from PA1 into U1, comes out of U1, and now the data wants to get into U2, but prior to the data getting into U2, pin 11, C has got to be activated for it to go in.
Exactly.
Okay, that's what I wanted.
That's what I asking you.
Let
Okay.
enable high.
From
And then pin 1 is output control.
to L2.
And somebody said pin 1 was output control.
Pin 1 will be output control. However,
Oh, go ahead. Sorry.
right now we're talking about L2 already get an input of 1D, 2D, 3D, right?
Right.
So we want that input go to inside L2.
Right.
Okay. Then what you need?
Pin 11's got to be high.
Yes.
Okay. What we need? Okay. L2 11 must be high.
Yeah, I copy off of Adam's paper.
We use this IC for, it was U5 in DLAP 9. So if you guys have that, look that up.
Okay. And that normally in the procedure, normally I using L2 lock. That's the function. L2. Okay, net L2 11 equal 1. Okay. And what I'm saying is, in the program, okay, you, I say, yêu chu lát. Okay. So when you get the function yêu chu lát, you call that function. They will be do the job. Will be bring yêu chu pin 11 to logic 1. And the data from the input yêu chu will be go inside of yêu chu. Now, they just go inside of yêu chu. And now you say, I want data going out. Okay. You say one data from inside. You go out to the output.
Pin 1 has to be low.
Then what can we do?
Pin 1 has to be low.
Exactly. Yêu chu pin 1. Yêu chu pin 1 must be 0. Okay. So in the program, okay, I using yêu chu output enable. Okay, then data will be ready at the output of yêu chu. So now I can give you sample. Okay, I say step number 1. 1. Okay. You write. This is not right, okay? Write to port A. Okay. And the data you want will be 0x 055, for example. Step number 2.
Shouldn't it just be 0x55, Mr. Pham?
0x55, sorry.
Sorry.
That 8 bit. Okay, step number 2. What next? Okay, you call a function yêu chu lát. Okay, so they will be load the data input yêu chu to the inside yêu chu. Then the next step. 3, what next you want?
U2 output enable.
Perfect. yêu chu output enable. So that will be routed. The input of yêu chu now go into the output. Okay, then you can reading.
Put a T after the U for out, Mr. Pham.
U2 output,
O-U-T. O-U-T.
out.
There you go.
And since U3 is grounded, the data will automatically show up at port C now.
Right. If
So you
you're
can
looking
read
in
the
the
data.
schematic here, you see it coming out here, they wrap in here, and you can read it and verify.
Right.
So anything wrong, they can be U1, U2, U3. However, also they can be U4.
Mhm.
I think it will be a control on this thing here.
And it's hooked up to those inverters at U10.
So that's a first to test, right, Wi-Fi, right, AA.
Mr. Pham.
Yeah.
If you bring up your notes again, just want to ask you. Now we have enable U2, enable the latch on U2, but we haven't disabled the latch after the data go in. Is it a good practice to go and set that to disable after you enabled it?
You mean,
Okay, you know where U2 11 is equal to high, you use U2 latch.
yeah,
So U2 is now enabled, okay?
last
Where-
they loading whatever here.
Right, right.
You
And
could have
they-
that built into the definition of U2 latch that you bring pin 11 low after you bring it high, and that data will stay inside.
Exactly.
So you,
Just a positive function.
right, you set it to high, then the data go in. So I guess we should set it to low again to
Yeah.
enable that.
Essentially, open the door and then close the door behind the data.
Right.
Right, okay, all right. I just wanted to double check that's what.
Yeah. The thing is when you're using U4A here,
Mhm.
they will be bring it up high, then they go low. Okay.
Okay,
The thing is, if you still keep high, whatever you jam in here, they keep going inside.
right, okay, so we have to close it, okay.
Okay. Now, that will be can be done for test number 1, number 2. Now the key point right here. You want to test the memory. Then you must be set the address. Okay. So in order to set the address, then you do the same thing. You write whatever address going here. You loading into U2. When they coming out here, U1 they go into U5 output. Only what you need to do will be
Clock pulse.
apply the clock. U5 will be 374. Electrical D flip-flop. They need a clock going 0 to 1. And whatever in will be going to inside U5. However, output control you tie to low. Whatever come in will be coming out. That means you set an address for memory. I just try to explain to you. I'm not going detail. Okay. I telling you what the function we want. And now you try to write what inside the function. I want to see how many people can understand. Okay, now that is your writing address to memory. And the next one, you want to write the data to memory. Okay, then whatever data you write, you have to write to port A, 55AA, whatever. When they go, they still go up to here. Now, this will be supposed to be go to the U6. U6 will be connected into the data memory. So in order to get the data go into U6, then also you need the U6 lot. That means pin 11 must be go high. Okay. Data load inside U6. Then pin 1 must be low. So data will be coming out here. Okay, now only the difference right here. The current data coming, okay, to U9. What is U9? Who knows? What is U9?
Tri-state auto bus.
They will be 245. I see.
It's a tri-state auto bus transceiver.
Okay, this get a buffer. However, bidirectional. What that mean?
The data can go both ways.
Go both way.
Data can go from A to B.
You can read or write to that.
Right. All data can go from B to A. Either one. Depend on pin number 1 direction. If pin number 1 logic 1, data going from A to B. If pin number 10, data going from B to A.
Hey, Mr. Pham, how do you know that?
Data sheets.
Data
Oh,
sheet,
okay, yeah.
if you're looking on the data sheet, I already gave it to you. guys.
No. You know, I got it.
Okay. Okay. The thing I'm not good than the other. Only thing I have to read,
Mhm.
just follow it.
Hey, Mr. Pham, so like you said, that data that came down and it went through U6, and then you start talking about U9. So on U6 pin 1, it's pin 1 is hooked to U45 and U91. So that means for it to go out of U6 toward U9, then it would U6 pin 1 would have to be low for that to happen.
Yes.
Right. You say get a 0.
Right,
It means the data go into the memory.
right.
The way we design, that means when I say U6 pin 10, I want U9 pin 1 also have to be 0.
Yes.
So data can go here. You don't have to do on U9 pin 1. That will be also controlled by U6.
U4 pin 5 controls U6 and U9, both pin 1.
Right.
The thing is the way I design, I want data go to the memory. Then U9 have to be going from B to A. Okay?
Yes.
Now, when you read the memory, that means you have to apply a thread. Same thing like we did. Okay. And the data from the memory supposed to go in out. Okay. And the data from the memory going out here. And they go to here. They go to U7. Okay. When you want to read the memory, then pin number 1 here must be 1. Okay. That means they want to disable U6 and they enable U7. When they disable U6, automatically pin 1 here now to be logic 1. And data can go this way. They're going down. They go to U7. and you read from U2.
Hey, Mr. Pham, can you repeat one more time? How did you disable U6? I missed that part.
U6 here,
Yeah, right.
you what you want. They
Disable.
if you want
The
out,
latch again. It's the latch, so it'll be built into enable U6. You'll get a pulse.
yeah, you want either one. You want the data load inside or you want the data go out.
Well, you said to disable U6, so I was asking you, how do you do that?
Disable U6 pin 1 have to be 1.
Okay, pin 1 have to be 1. Okay, yeah.
Output control.
Oh, yeah.
The thing is U6, U7 share the same wire.
Yeah, right.
Only one enable at a
Yeah,
time.
because if pin 1 is high, then nothing can come out of U6.
Right, they be tri-state.
Right. I got you.
Pin 1 is 1. That also telling you pin 1 U9 also 1.
And
And
again,
all,
U2 and U6 are the same IC.
yeah. So that one, so the data now will be go A to B. And they going down here. And you enable U7. Data going that way.
Yeah.
And you can reading from U3 here to proceed. That's it. The whole lab
It's two.
will be nothing else. And now, before we quit it, I can get you see that one.
So if we finish D-Lab 10, work on D-Lab 11, right, Mr. Pham?
Yeah, that's what I wanted.
Okay.
Mr. Pham, I was looking over the sheet for D-Lab 11. Does it require an array for us to use to do this D-Lab?
Same thing.
Same array?
Yeah,
Just copy it from D-Lab 10?
right.
Okay.
Now, on that one here, I will be given to you that you must be following. The first one data here is still the same. Okay, now, this is the one you have to follow. I already get whatever I wanted. Okay, so you will be do exactly. U2 lab, U2 output enable, U5 block, U6 lab, U6 output enable. And this is a decoration or prototype of the function we want. Okay, then you can go into the function definition area. Okay, that means after the main.
Right.
Okay, make sure you understand. Otherwise, the people screw up.
Function definition always go after the main.
Right. And now just do it one at a time. Void, U2 lab, I don't care what will be here. And you get another one. Try to get all of the function definition. Okay? Until you can get everything. Okay? That's the function definition. Then now you compile. Then I don't think you get any error. Then what you need to do, and now go into the U2 lab. What you want to do here in order to get the data, get inside U2. That's what I want you to try. I want to see how many students can get that function.
That's like write to port B or something like that.
Yeah, whatever. In order for the data can go in from input to the inside.
Right.
After that, then you have to go to the next one. Output, you to output enable. How you able to set the data can be from inside of you to go to the output. Okay, you write port A, port B, or whatever. I want to see how much the student can understand. Okay, any question? If you get any confusion, anything else, you can get Zoom with me. Okay, you understand when you learning electronic, you learning DC, AC, electronic, and the basic digital. But that will be basic understanding electronic. But it's hard to be a real technician. A real technician in a company is fix the problem. When you run the test, it fails. How can you fix it? That is the key point. We want to teach, but look like the people still cannot get through the very, very basic. Then they cannot get more, get understand more. Okay. I can give you the example here. When you want to test the memory, okay, you write a thread here, you write a data going here, okay. Then when you get the memory, you will be read after you write it, and now you can read the data from the memory. And when it fails, they display for you. And basically, you don't know what to do. Even you're working in the lab, you write the data address here, okay? And then you write the data here. You apply right, they will be right inside, okay? When later on you want to read, apply address first, and you want to read, data will be coming out here, going down here. Now, when it fails, everything already done. So you don't know how to troubleshoot it. I given you an example. In order to make sure the data write to the right location, and when you write to the address, you can check using the meter to check the location here. 10, 10, 10, 10, 10. Okay. And also you can using the meter to check the output here. 0, 1, 0, 1, 0, 1, for example. And make sure pin right supposed to be 1 for read. Make sure pin 20 to be 0 for the output coming out. Make sure pin 18 will be 0. Okay. So look like everything okay. However, we don't know that when you write the data to the memory, it's a right data or wrong data, right address or wrong address. So that's why when you write to the memory and you want to check in here, then the computer not stop for you to check it. Then you have to stop right here and check to make sure the data is right. If data is not right, then you have to go back here to find out. And also when you write the data into the memory, data here, okay? But the thing is, you cannot stop the program, okay? You can say, when you write to the memory, now you see that? Write address to memory. Then after that, they go right away, write data to the memory. Then you say write memory, okay? And next they get another one. So how come you take, when you say, I want to write address to memory, you want to take, make sure you get the right address. What can we do?
Put a pause.
Who want to know? Okay, yeah, I see you what you say. You can using my program, using pause, right? This function will, when they go up to line 137, they stop. You see that?
Do we need a declaration and a definition for that?
No, that's a system.
That's built in. Okay.
Okay. Now, we don't want to do that. Well, what else? I want to take you just a few minutes.
See out maybe?
No.
No?
CLR, that means you're just talking about software.
Right, but then you
Right
can,
now, we get a problem. We want to take on the hardware.
okay.
That means you have to using the meter to take, make sure you get the data AA.
You mean to do like debug?
Exactly. That's what I tell you. Now, you go to,
Debug.
okay, normally you run without debug. You see that? And now you want to run debug. So before you want to run debug, you have to know which line you want the program to stop. I say 136. I click here. You see that? Red one. When I run debug, okay, debug run with the debugging.
It'll stop at 136.
You see that? Now they stop right here. So you can do whatever you want.
And so that will hold those pins at that logic until you can test it with the meter?
Yeah, you can press F10.
Okay.
We'll go down to the next line.
Okay, F10, they go to the next line.
Or if you want to go through the function, you press F11, right?
Yeah. If
F10 will go line by line, one at a time?
If you write on the line 136 and you want to jump into the function write address to memory, press 11. F11. Then they jump into that function. That's a tool for software. Everyone want to write a program, they must know that. In order try to tracing out what's going on, what's wrong.
I have a question, Mr. Pham.
Yeah.
How you continue debugging your code after it stopped up at 136 at the line 136? How you continue moving forward in your through your code?
Now, what I'm saying is, when you run debug.
Yeah. Let's say we are in the debugging mode.
Okay. So when you run debugging, They
Yep.
stop at line 136.
Yes.
If you want to go to the next line,
Yes.
press F10.
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 Okay. Okay.
If you want to jump, if you want to jump into the function, write address to memory, press F11.
Okay. Thank you.
Every time you press F10, they just go to the next line. They execute line by line.
Hey, Mr. Pham, so what does F9 do then?
We don't have F9.
Only to F10 and F11?
All right.
Okay, thank you.
And mean go to the next line. F11, jump into the
Function.
function.
Okay, so just those two.
This tool I have to be using on the time. You know why? When I try to design the lab, and also I have to write a program to test, make sure they're working.
When you say jump into the function, what exactly do you mean by that?
They jump into the function definition of,
Okay,
of that function.
I see. Okay, thank you.
The thing is, sometimes you want to know what you're doing on that function or what they doing.
Hey, Mr. Pham, the only problem with this is, I know you're telling us and you're doing a good job at this, but when you jump into F11, it's like 2 or 3 boxes show up. So how do you know which one you should be looking at or what?
Now, if you press the F11, okay, I try to, let's see,
You're already on debug, so if you just press 11 to go
I
to it.
try to build it first. I make sure I get a 0 error.
That should automatically bring you down to the function definition.
Okay, 0 error. Okay, now build debug, build run debugger. Okay, so right now you're here. Okay, if I press F11, let's see.
Do you need to highlight the script on that line or something?
No,
Or have your cursor on the line?
no.
There already.
They're supposed to be jump into this function. Okay.
Hey, Mr. Pham, but does it have to be a mistake for you to do this, or do it have to be correct?
What do you mean?
For it to jump in the F, if there's no error, then
Will it still bring you to the definition?
yeah,
If it's correct?
that's what I was wondering.
Let's say stop debugger now. Okay. I try to debug again. Okay. Debugger. You see, I supposed to press F10. They're supposed to go to the next line. But in this case, I don't know why they're not. I will check that. Okay.
That's what I was asking, Mr. Pham. Since your program is perfect, maybe it's not recognizing anything wrong.
Okay, I see that.
Here we go. Now we're at 136. Now press F11.
Okay. Now, the thing is we already get the one I already ran it, and they still in that, so that's why they're not working here. Oh, I see. Now they not really.
And then of course your function is empty.
Yeah, my function have nothing.
Right.
Oh, that's why?
Okay.
Maybe you have to do a different function as an example.
Okay.
There's no definition for that function right now.
Yeah. Now, if I want to stop right here, okay, measure, and I put a not here, Okay, try to see. I have to close that guy. Okay. Debug, start debug. Okay. Right now you see they get an error. Okay. If you want to go to the function, then you press F11. If you want to go to the next line, F10. See that? They go to the next line. Okay.
Do F11 again.
Now F11, they will be go into the system test evaluation. You see?
Yep.
You see
Okay.
that?
Yeah, now, once you get here, Mr. Pham, my question is, once you get to these boxes down the bottom, how do you know what to look for or what you should be looking at?
Now, depending on what you're looking for, you want to see what inside that evaluation they doing. That's what they do. No go form, whatever.
Like for here, you have two variable, which is the expected and measured. So at the
Right.
bottom,
But
you
this
see
is a
that.
my program. It's not
Right.
your.
Right,
But
but
it's not hooked up, so your measured data is 0, but the expected data was 85.
right,
Yeah.
but
But
that's
then
the
you go
window telling you the data.
to the IO.h. Okay. Let's go to the IO.h. My program, not your program.
Right.
So if you press F10, you can see, keep going down. Now they're going back to your program. So now you
Oh,
understand.
it jumps back to the main after that.
Right.
Okay.
In the function, it go back to where it
Right. After the line, test evaluation, and they go through the function and go back to next line.
Now, right here where it's got, for the expected data, it's got 85 and the measured data 0. Where's the 85 on your program?
Expect data 55.
It says 85 where it says value.
it would be the line, a couple of line above wherever you had typed in your expected data. For whatever test it is, when you type in expected data, then that's what will show up there.
When,
Okay, so why does he have, it says no go, true, expected data 85 and measured data 0.
That's his loop to saying,
inside that fail or that part, but that basically inside the that evaluation.
Okay,
They compare what you want, what they measure. If they are same, then they say that part.
mhm.
If they different, they say that fail.
Okay, and that's what the no-go true is, test failed there.
Right,
Because expected data is 85 and measured data is 0.
right.
Okay.
So that means this is in the system function. So you don't care about what inside here. But I just bring it up for you. If you want to go into any function, then they can jump into that function, F11. If now I press F10, you can see they go next line. They go next line, keep going. See that? And also you can see, okay, expect value in here. Okay. And if you see right here, a very small one, expect value, they can telling you what the value, 170. They're using the decimal.
Oh, okay.
170 mean AA.
Oh, I see. So the 170 is AA then.
Mm-hmm.
Oh, so when on that other one that I asked about, when I saw 85, that was a decimal number that I would have to convert over to,
Bye.
yeah, right.
It wouldn't just be 55 in
No,
decimal.
the
Right.
computer don't know height.
Right.
Right.
Okay.
Only
That's what I
know
was
the
confused.
decimal.
That's a 8-bit binary number.
Right. Binary.
Okay.
Yeah, that's good information, Mr. Pham, because I think we all thought that that was we didn't know that that was the decimal.
Yeah, I was a little confused. Thank you.
Okay, that's good enough. Next time.
Hey, Mr. Pham, but the best way to do this debugger, it needs to be hooked up with the software and the hardware, right? And then you can see better.
No, yeah, the thing is you need it, you don't have to get the hardware. If you want to see the data, you see your program right or wrong.
Oh, okay. You don't need the hardware to use the debugger?
No. Okay,
All right.
so this is the last one. I can give it to you guys. Without knowing debugger, you cannot be a programmer. Even you're not doing in electronic, you can working in anywhere with the software without debugger, you cannot do your job. You write a program and you want that is the output and they coming out, it's not right. The output you want. That's why you have to take it out to see what's wrong, where wrong. That's why you need debugger. I using all the time when I'm working on the C++ software. Okay? So we'll make sure next Monday, no class.
Hey, Mr. Pham, so we do this D-Lab 11, we do this based on the handout schematic you did, because you didn't really put it on the web yet, correct?
I put already on the web, on the handout.
But it's all composed of things we've already done. It's just kind of put in a different order, basically.
Okay.
So use your DLab 9 program and look back on what we've already done.
Okay, to do D-Lab, to do D-Lab 11.
Yep.
Okay, got you.
And like he said, you use the same array from the last DLab that we used, because you need an array for this as well.
Okay, got you.
The thing is right now, I'm not trying to put it into the assignment. The thing I just want to you guys show me.
We've used all these ICs before. They're just in a different arrangement.
Yeah. For each function, you have to tell me what's going on inside. Okay?
All right.
You see?
Thank you, Mr. Pham.
Thank you, Mr. Pham.
Yeah, no problem.
Have a good holiday, guys.
Okay. Thank you. Good night.
All right.